Good afternoon or good evening, depending on where you are, and welcome to today's DevOps.com workshop, brought to you by Techstrong and Menlo Security. My name is Cody J. Brown. I'm the host of Techstrong Learning. We've got an exciting workshop ahead, but first I have just a couple of housekeeping notes to cover. First, today's session is being recorded, so if you'd like to rewatch, follow along later, the on-demand will be made available shortly after we conclude our live session today. If you have any questions, comments, concerns, if you just want to let the speakers know your thoughts, the chat section is going to be your best friend today. That's going to be our main way of interacting with one another. So please participate with us there. We also, I believe, have a couple of handouts underneath the screen that are there for you to aid in today's workshop. And before we close, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. So our workshop today is titled Fast, Reliable, and Secure Access to Private Web Apps. And joining me is Eric Shawake, Senior Manager of Cybersecurity Strategy at Menlo Security, and Ryan Helwig, Cybersecurity Engineer at Menlo Security as well. Ryan, Eric, thank you both for joining me. I'm going to let you kick us off.
Hey, thanks a lot, Cody, and thanks again for everybody's time and joining us today. You actually get a little bit of a twofer in today's session. We're going to do a bit of a demo and some conversation around Menlo Private Access, which is Menlo's Zero Trust Network Access solution. In addition to that, we're going to talk to you all about a new category of threats we've classified here at Menlo Security called heat attacks, highly evasive adaptive threats. So I'll walk you through some of that via slides, and then Ryan will be the brains behind the whole operation, and he'll be giving demos of both of these things. You can actually see in real time, how to deploy and use Menlo Private Access, as well as sort of what heat attacks look like and how Menlo can help solve for some of those new threats that are out there. As was mentioned, please, if there's questions, comments as we go through the session today, pop those into the comments or chat section, and we will try and get to those as we have time. So with that, I'll go ahead and get kicked off here and sort of start talking about some of the stuff we're doing here with our Menlo Private Access. Before we sort of get into what the solution is, of course, we want to talk about how securing remote access has obviously changed in the last, well, definitely since COVID, but even before that, it was changing as well. The old models, as far as trust was concerned, it was really around, sort of trusted everybody inside an organization. Let's not trust anybody outside that organization, right? If you're security people that have been in the space for any number of years, that's the world you lived in as far as, building up those VPNs and firewalls and all that stuff around your headquarter locations, and prevented any kind of threats outside from getting in. The new way we should probably think about that is really trust no one. Because honestly, the fact is I or anyone else in an organization, even though I'm a security conscious user, I could be compromised by a breach, by an attacker. And so you should never have full trust in any of your users necessarily within an organization. There always needs to be security tied to those users to make sure that they're not maybe compromised and doing bad things in the environment. Of course, we know remote work has changed dramatically as well. It was, 25% of the workers used to be remote, which was sort of more easily managed with the old legacy VPN architecture. But now, especially after COVID, it was nearly 100%, even with folks now going back to a hybrid place and the hybrid workforce, we're still seeing around 75% or more of users could be remote at any one time. And of course, that leads to issues with VPN overload and those sorts of things that you're having to struggle and deal with. And then, of course, apps and data, that's changed dramatically as well. 10 years ago or whatever, all the applications and data, they might have resided within your confines of your solely managed and secure data center, where now businesses are driving a lot of stuff to the cloud. Digital transformation is one of the things you hear a lot about, which, it's a buzzy word, and it's basically, the folks on high are saying, hey, we see economies of scale moving this stuff into the cloud. Let's do it and move it into the cloud. And then it's up to us on the security side to figure out how we secure that stuff, which is problematic, right? If you have apps and data that are outside your control, out in some public clouds or whatnot, making sure that information is secured is becoming quite burdensome. And so you sort of change that mindset. We'll talk through how we sort of do that with our solutions. Of course, Gartner and others are seeing this change as well, as far as ZTNA and zero trust network access being a way of the future. Gartner, that quote there at the top, basically is saying, at some point VPNs will be supplanted by zero trust network access architecture. So the idea there, of course, is VPNs much too permissive as far as trust goes. You need to move to a ZTNA type of solution to bring in more explicit trust to those users. Gartner also says by 2022, this year, many organizations are going to be moving to ZTNA solutions for partner ecosystem access, right? So if you think of all the third parties or partners you might work with in your organization, how do you provide secure access to those individuals that might not be a fully vetted employee or whatnot with your organization? Well, ZTNA is a path to do that. By 2023, Gartner is expecting that about 60% of enterprises are going to phase out almost entirely access to VPNs in favor of a ZTNA architecture. Right? So that's just around the corner. So what are plans within your organization to do that? Are there plans, or is it in the works? Because it can be a big hill to climb to get there, but it is something that does have a lot of benefit over your traditional VPNs that you might be using today. And then finally, ESG says about 83% of organizations are going to allow personal device access to applications and data, right? So as a security member as well, a security team person, you might be like, well, that's not great, right? If my organization's allowing their employees to do this, that's maybe makes the business work better because people are, can log in on any device from anywhere in the world. But from a security perspective, of course, that's very challenging because you don't have direct access to that device, perhaps. You might not be able to put all the security controls you want on that device itself. So how do you help solve some of those problems? So when we talk to customers, there's a few big use cases for zero trust network access controls. The first one we talk about a lot is the business critical applications. So if you think about it in your organization, you probably have a good chunk of business critical applications, and it can range, right? Depending on your organization, it can be, I've talked to companies who have maybe 5 applications that are sort of private applications. And by private applications, I mean, not like G Suite, not O365. I'm talking about, Confluence, Jira, maybe custom built applications. But depending on your organization, you might have, 5 of those. Some organizations have upwards of 100 or more of these business critical applications that they need different entities in their workforce to have access to. And that is office employees and remote workers, right? So as we, those are vetted folks that might need access, but also it's third parties. So how do you make sure that all these different users connecting from all different places on different devices who might have, might not be employees in any sense, right? They might be just third parties or, contractors or whatnot. How do you provide them secure access to those business critical applications in a seamless fashion? Some of the use cases we've seen directly here at Menlo are things like retail organizations. So being able to have folks upload product safety reports to a centralized application it can be a challenge. If you just have an exposed website where you would normally do that and people can just log into that and try and upload stuff, of course, there's a target that attackers can go after. And so how do you sort of not expose that directly to the web, but still provide easy access to folks who need it? We've also seen transportation companies needing this kind of access for scheduling applications or managing workflows in an organization. But again, that's one of the big things we're seeing with a lot of companies is this question about how you provide that access to these users, to these business critical applications in a seamless and secure fashion, being able to scan for malicious content, various things like that. The other big use case we see is being able to provide internal web application access to from unmanaged devices. So as you can imagine, you might have internal resources on your intranet or whatnot. Traditionally, of course, that's with a VPN. You just say, "Here's your VPN access. Get at, can go at it, and you can get on there." But again, thinking about VPNs. Of course, the VPN technology is much too permissive. So you might not want to give that to everybody. They might not need full access to the network, and when they're getting access to these applications. And if you have a third party, you probably can't deploy VPN, right? You can't deploy an endpoint agent to that third party's or contractor's device to actually get them access. So a zero trust network access solution really can help solve that hurdle. The other one we talk about a lot is mergers and acquisition integration. So, if you're in an organization who is part of M&A activities. And this is one that doesn't happen all the time, of course. I mean, you're not doing M&A on a daily basis for sure. But when that does happen, you can imagine how complex that's going to be, because you have two completely disparate organizations, IT infrastructures, all this stuff, but there are probably shared applications that need to be accessed by all different groups within those, right? You might have a finance application that both companies might need access to while the M&A is happening, or different things like that. And so being able to provide that seamlessly and easily is another really strong use case for a zero trust network access solution like we have. And then finally, VPN augmentation replacement. Gartner has their number around 60% by 2023 are going to get rid of their VPNs. I don't know if that's true, right? I mean, VPNs have been around for whatever 20 years, and they have their purpose and they have their place in organizations. But what I would say is that a ZTNA solution can really help augment that VPN capability. And by that, I mean, if you have something where many users are going to need access to these applications, let's say COVID happens again. Let's not say that. Let's pretend it doesn't happen. But if it does, and everybody goes back, and we're back to 100% workforce remote, VPNs might not be able to scale to that. So how do you provide easy access for that, right? When folks are working from home, into the future, rather than having a VPN that they've got to connect to every time, because we all know, and I have this problem as well. I might not want to connect to my VPN. That's the most secure way to access all my applications. But if I can just do something without doing that, I might try and not access my VPN, which again, just sort of breaks that security tie. And so how can we help that with a ZTNA architecture? There's some great ways to do that. And sort of we'll talk through those in a little bit. And Ryan will actually show that in some of his demo as well. So those are sort of the primary use cases we talk to when we're speaking with our customers, those four I just share with you. How does Menlo fit into that? So Menlo Private Access is a ZTNA solution. It fits right in the middle of all those use cases we sort of spoke about, right? So at the end of the day, it's you have your user access on the left, you have your private applications that users are trying to access on the right. How do you make that as seamless and secure as possible? So what we talk about is sort of three big tenets of that. One is the user security, making sure that everything around the user is secure, making sure that application that they're accessing stays secure, doesn't get corrupted by malware or things like that. And of course, the data that is most important to your organization is in those applications. So how do we make sure the data itself also is secure at the same time? There's a couple of few points, and I'll actually cover in a couple slides those three in a little more depth, but just to let you know, there's some at the bottom, we have four sort of big things that we talk about here at Menlo that sort of differentiate us in this regard. The first is isolation core. So Menlo has what's known as our isolation core that powers all of our security technologies, web gateways, DLP, CASB, all that stuff. But it's also part of the Menlo Private Access solution. We'll talk about how that can help you with some of these other slides I'm showing here, but it does differentiate us in that all communication and traffic flows through that isolation core. So we can do really cool security controls around that other vendors might not be able to do. Also very low friction end user experience. So it's very easy to onboard your users. We don't want to introduce something that's going to make it more complex. That's the last thing we want to do, right? We want to make it as easy for that user to get their job done as possible. And the way we have and Ryan will actually show this in his demo, how easy it is once it's configured to have these users actually access the applications they need to do their job. We're also very easy as a deployment solution. Ryan will talk about this as well a little bit, but there's really low requirements from you as security or IT teams to actually get this thing up and running in your organization. And then the other big thing we talk about a lot is their integrated approach to all of our solutions here at Menlo. So whether it's our web gateway, whether it's our DLP, or whether it's our Menlo Private Access, they're all managed from the same management console. All policies are in the same place. All the reporting is in the same place. So you're not going to have your team or you learn and manage different consoles. We think that's very important when you're going through a transition like this, is to have one place to go and not have to learn different things. So how does our solution work? This is the clientless, and we'll actually, in the demo, you'll see that Ryan will actually show it in real time how this works, but it's actually fairly simple, right? So there's a user portal that the user will access to get their applications that they need to do their jobs. All of that action, all that communication, it goes through our isolated access in the Menlo cloud. So like I said, the isolation core is the intermediary between all this communication. We established a secure tunnel with any of the applications you have, and those applications can reside anywhere. I mean, I'm sure you still will have applications in your data centers. You probably have applications out in the cloud and public clouds and private clouds. It doesn't matter where those applications reside. We can connect to all of them. And then what we do is we render that information back down to the user's device into the browser. So in our estimation, most of the time you think about applications that you're using. So again, I go back to Jira or Jenkins, Confluence, any of those applications, the vast majority are going to be browser-based. And so we tell our customers, hey, if you have browser-based applications, that's where you should start. Don't just deploy another agent. That's the last thing we want to do is to try to deploy another agent. And of course, via contractors, that's not going to work in the first place. So look at a clientless solution first. And we have, because of our scalability, we can do this at scale, right? We support very large customers, so we can enable a clientless first approach at scale, which is going to be much easier to deploy, much easier to get up and running. As you see here, no agent required. There's no DNS kind of modifications or certificate changes required to do this, like some of the other vendors that are out there. And we lead with this because, again, we see that most of the organizations will need and will be using browser-based applications. At the edge case was where you have applications that are non-browser-based, then we can talk about the client. It's a very similar approach we have with the client, but we want to lead with the clientless first because that makes most sense for many of the organizations. So let's talk about the couple of things before we go into the demo here with Ryan. But again, it's about securing the application, right? So if you think back to those portals that might be out there, whether it's an insurance portal or some other more specialized portal that a transportation company uses, where they have folks logging in, uploading information, we want to get rid of that exposure. And so a lot of the capability we have with Menlo Private Access is to reduce that exposure for the application, protect the application itself. So we're able to isolate that user and isolate the application itself from the broader web, right? So we really drastically lower the threat footprint of that application. We can do really cool things where the isolation core is part of that. So it's going to make sure that when the user accesses it, they're not accessing the direct application itself. They're accessing a re-rendered, isolated version of that in the browser. So even if that user becomes compromised, that attacker, if there's an attacker there, they're not going to be able to access and cause harm to the application itself. One of the use cases we've seen with this is the Log4j. You probably all had to deal with Log4j at some point in the last several months, I guess, but there's a long tail of that. And so we're hoping that this ability will be able to protect a lot of those applications that might have been vulnerable to Log4j issues. Again, also, it's about securing the data. The data is most critical to your business and keeping you up and running. And so because we're always in line of traffic at all times, we can do things like DLP controls in this traffic, right? We're not just establishing the initial secure connection and getting out of the way. We're constantly in line so that we can do DLP queries on the traffic. We can do different read-only access or control file uploads and downloads. So it's really about making sure that we stay in line. As users are accessing that data, they can't accidentally or maliciously leak data out of those applications and cause harm that way. And then finally, it's about securing the user themselves. So, because again, we're in line at all times, we can make sure that if there were perhaps malicious content either on the user's device and they try and upload it to the application, or vice versa, if there's maybe malicious content on the application that might try and get down to the user's device, we scan traffic both ways and make sure that any of that is going to be blocked before that impacts either the user or the application itself. And so that's a really big differentiator for us, that we can apply those security controls to it as well. The other cool thing we can do is if you want to provide access, let's say you have a portal that has a lot of like PDF documents or Word documents or whatever they are, we can do document isolation as well, where we say, if they're going to browse and see a PDF, it's going to render that in isolation rather than the full actual document. So we can defang any kind of malicious content that might be part of those files that are in the application the user is accessing. With that, I'm going to go ahead and kick it over to Ryan to show you how quickly and easily you can actually set this up. Again, the idea with this demo is to show you the simplicity of the solution, to hopefully give you some confidence that, hey, if you decide to go with something like MPA as a solution to your ZTNA transition, it'll be a pretty easy move for you to make. So with that, I'll go ahead and pass it over to you, Ryan, for the demo.
Yep. So real quick, it just adds a real world context to what we're talking about. I'm working with a customer right now, and they're an insurance organization that has an internal application that is in-house developed. There's security findings against that. And in order not to disrupt any of the business, because they have external contractors that do quoting, and it's really kind of the wild, wild west with that application. But because of insurance and the regulations that coming down with that, they need to be able to protect that application and make it seamless for their agents to be able to make quotes and stuff. So one of the use cases, just as a real world use case that we are working with right now, is to be able to provide protection against that application without having it to be published externally to those remote agents to do quoting. And from that, we can control what give them more control on what their agents can and can't do. But before jumping into some of the catalogs here, basically to set up the plumbing of this is really quite simple. In fact, the OVA appliance that sits in-house in either your cloud or in your local data center, it basically establishes a secure connection between the app and Menlo's platform. And so with this particular example, we have Splunk internally here. And really what you're doing is providing the access. There's no DNS changes. It's going basically right off of what you already have configured. You're saying, hey, here's what you're doing when we make requests from the cloud to wherever the application is, saying these are where the DNS servers are. You create the cluster, as well as connecting that, creating a connector to connect to that application connector to wherever it's pointing to. So for instance, this is just setting up the connector, basically laying out the plumbing. You say what region it is in, right? So this one's happened to be in Northern California, and then that provisioning key to allow for a secure TLS connection between our platform and the connector that is communicating to. None of the traffic is exposed externally. It's all maintained through a secure channel, through secure communication. And what I'm doing now is, once you have the plumbing laid, the connector set up, you've already made the established between the app internal or in the cloud, wherever it is. Now you're going and configuring the application catalog. What applications do I want to enable within the portal? You see here that there's a couple here that are configured. I'm just going to keep using that Splunk example. In Splunk, we've given it a name, and this is an internal application that we have. It's not published anywhere. It's internal. In order for me to get to that, I have to actually VPN in. And I'll show you here in a second how we're able to bypass a VPN and allow connection to an internal app. But in this, you're giving it the web front end. You're telling it, do I want a timeout? So you have controls around how long those users can be authenticated, as well as what the connector you want it to connect to, right? As I showed you, there was a Splunk connector. We're using the Splunk connector because it's provisioned for that application already. And then if you wanted to tie any type of policies around it, so allowing DNS access, allowing it to make queries, allowing it the type of communication that you want it to perform. Once you go and set up the application, right, you're adding apps, all those, any internal apps, like Eric mentioned, starting off of those web apps, those things that are the low-hanging fruit, and working into more of the complex applications. You create your application catalog, and then what type of rules that you want to put around and who has access to the application itself. So in this access policy, I can specify where access can come from, who can access it, all right, what regions. So if you want to only lock it down to particular IP ranges, you have the ability to restrict that access, as well as what applications rules that you want to apply. So in that previous slide where you're setting up the application, this particular policy applies to just the Splunk application itself. We have the ability to either do local login to the app. So if you have local user credentials, or if there's like an IDP or a SAML type brokering request to those applications, we could support either or. And then what Eric had mentioned in this policy, what you want to allow and how you want to allow access to the application is one of the one of the differentiators that we have, because we control that session, we're able to get deeper into the communication channel. And so either allowing downloads or allowing uploads is really all there is to it for configuring it. Now, to show you an example of for instance, the internal app. So I'm not VPN'd in. I don't have access to it. And so as a user, you see this is an internal web link to the application. I don't have access to it. But to show you the user portal, this is a portal that is configured for my user. So I have access to these applications based on the policies, and these are what I have and access to access. So without VPN in, I can click on the Splunk link, which we had gone over in this example, and it is brokering the connection to this internal Splunk app. What you'll notice here, and I'll just leave it with that, is the link that you'll notice is the link to log into the application itself. What we do, and what makes us to be able to control the session, is that we prepend this link with it pointing to our isolation. So any of the links, it's all going through our isolation core, which is what Menlo is about. Everything is through isolation. So as you look at users that are maybe outside of your control, or users that are remote, or they need access outside of, not opening up VPN, right? But you need to be able to control the access to the app and be able to publish it for those remote without giving them VPN credentials. You have the ability to send it through Menlo's platform, control the session, which we then will inspect the traffic, whether there's viruses that are inside of it, DLP rules, policies, and even allowing or disallowing what they can and can't do with the app. So if it was configured for read-only, I'd just be able to access the application. And in the example that I gave when I first started this, the use case for this insurance company, because there was an audit finding and it was an in-house developed app, it would have caused more development time and cycles to be able to remediate the audit finding. Instead, we're able to do a compensating control around that application. They can close down access to the app, as well as providing access to all those remote users without compromising the application itself. And so really, that's it. That's all there is to it.
Yeah, it's good stuff, Ryan. I mean, I think, the point with this demo is obviously show you folks on the call how simple this is, right? I mean, so there's other stuff that goes into this. I mean, I think, talking to customers, one of the big things is they've got to sort of get their arms around the application proliferation in their environment. So depending on how big your organization is, there could be all kinds of applications you don't even really know about, right? I mean, it could have been some group of 10 people that bought some application and they're just using it. So I think a lot of the initial legwork is just sort of getting that sort of repository of applications together, right? But then the idea is once you know that, like once you know your business critical applications you need access to, the process of actually setting us up and getting us in line is quite simple. I've heard, I don't know what your experience was, Ryan, if you've actually done any deployment with that customer yet, or if you're still just talking to him. But one of the customers I spoke to or had spoken to or heard about, they did a deployment in just a couple hours, right? I mean, it's really simple to actually get this thing up and running once you figure out the applications you know about. And that's the idea. We don't want to make this a burdensome task because there's a lot of stuff you're already dealing with anyway in the security front. And so we want to make it as simple as possible to actually get configured. But also, of course, there's all that security we have tied into the back end as well. That's going to make sure those connections stay very secure. So if we go back and pass back to the slide, that'd be great. And then I'll get back to just some wrap ups on MPA and some of the business benefits before I go into highly evasive adaptive threats. But of course, we sort of talked about this and Ryan shared some of this on the demo as well. But again, it's going to improve performance across the board. The Menlo platform is a global platform, so it'll scale to any needs you might have, no matter how big or small your organization is. We can scale to whatever needs you have, and it will be a seamless experience for any of those users. Of course, because of the security controls that we talked about, both Ryan and I, they're going to have very strong security capabilities at all times with these connections. There are some others that I won't name names, but they don't necessarily do all the security controls that we do, which we think is very important. Just because you've established a secure connection tunnel between user and application, you should still tie security controls to that as well, because you never know if they could become a compromised user or if there's some malicious content on the device or on the application, whatever. You just need to make sure there's always security there. Of course, because of the deployment flexibility, we can make sure that you're going to be able to support any kind of device, regardless if it's unmanaged, managed, third party, and it's going to be consistent. So if a user transitions from their work laptop to a home desktop machine and they want to access these applications, it'll be the same URL they go to, like Ryan showed you there. And those the page will look the same no matter which device they're using, and so they'll have the same experience. And of course, because we're not, there's no hardware to buy in any of this stuff, it's all cloud-based. Gonna get rid of that CapEx that you might be used to having to deal with your legacy appliance stuff that you're working with, and it's gonna be this predictable cost. So regardless of how your workflow is, we know at Menlo your workflow is going to change over time, both up and down. We don't, our pricing doesn't fluctuate based on that. We will, it's a predictable cost when you get into this solution. So with that, I'll go into talking about heat. And I don't know if you folks have seen any of the other webinars or seen any of the other articles we've written on heat, but I wanted to give a quick overview of heat to give you a sense of what that's all about. And then we'll show a demo of it as well. So heat, again, stands for highly evasive adaptive threats. It's a new category of threats our threat researchers have discovered over the last 6 to 12 months. It sort of is a bit of a game changer in how attackers are going after organizations. What's driving this change? Obviously, on the left-hand side, we see some reasons why attackers are looking at ways to do different things. They understand organizations that they're attacking are moving a lot of things to the cloud. This digital transformation is exposing a lot of those assets that are out there. And so they're trying to take advantage of that. And they also understand that this remote workforce is using the browser as their main working tool. And so they've looked at that to figure out, okay, if this is the main tool that users are working, how do we exploit that as the tool and try and get bad things in there, right? And so what we see is a lot of times why they are doing this, of course, is the financial motivation. There's a lot of money involved here. And, we hear a lot about ransomware. When there's a big ransomware attack, I would say that's end stage. The ransomware request is the last thing these attackers are going to do. The first thing they're going to do, and once they get their hooks in, is sort of look at your network and figure out what's going on and exfiltrate data, steal data, because they can always say, if you don't want to pay the ransomware, well, we've got all your data, and then do you want to pay it? Do you want to pay us for that data we've already stolen from you? So the ransomware thing, where it sort of blows up and it's like, hey, we've got your stuff and we're going to lock it down. That's sort of after they've done everything else in the organization, which is sort of what they're trying to do. Credential theft is a huge thing, and it continues to be a main entry point for these attackers and dropping their malware. And then these attackers also, they're quite sophisticated, and they understand that the security stack we're all using is quite fragmented and is not easily managed. As you probably all know, you probably have multiple security tools in-house currently today, and trying to keep a handle of all those. And the alert fatigue that comes with all these different things throwing up alerts, the attackers understand this. And so they take that, they exploit that to try and, be as silent as possible to get into your organizations to do their bad stuff. So what are some characteristics? And we'll go into a little more depth on each of these characteristics as well. But the four main characteristics of heat are being able to avoid static and dynamic content analysis. And that's something like that you might have heard of called HTML smuggling. We'll give an example of what that sort of means. The attackers know that the email channel has been pretty locked down over the last few years. Phishing attacks were the way that they all got in. All the organizations have put a lot of controls in that email channel. So they're looking to find ways around that. And we'll talk about what they're doing there. They also have seen that sort of the categorization tools that we all use on our web gateways or other proxy controls are not as effective as we would hope they could be. And so they're looking at ways to sort of evade those categorization engines that we rely on to protect us from malicious content. And then they're also using dynamic encryption and dynamic phishing detection capabilities to avoid some of the detections that we have built into our tools as well. So let's go into a little bit more details on all four of those. The first example that we're seeing a lot of is this highly evasive adaptive threats. The idea here is that with this new capability in HTML smuggling, the attackers will load down blobs of data to the browser that are by themselves. Each blob is non-malicious in nature, essentially. So, to a web gateway, even to an endpoint agent or endpoint security solution, it just looks like some random data that doesn't look malicious. And so what happens though, is that once they've done that, and once they've evaded those controls in the middle there, once they've evaded the AV, the sandbox tools that are there, they then reconstruct themselves in the browser as a malicious file. So they've essentially evaded quite a bit of your security stack, and then they're in the browser, they reconstruct, and they have this malicious file that can do whatever it wants to do. And so this is one of the really big things that we're seeing a lot of these attackers use is this capability. And it's quite troublesome because, again, it's basically able to avoid that stack there in the middle. And if you think about that stack in the middle, right, the sandboxing, which we hopefully will catch these kinds of things, that capability, that's around 10 years old, right? And so these attackers have had a long time to sort of figure out how we're going to get around that. And this is one of the ways they're doing that with HTML smuggling. The second one that we're seeing more of is the attackers trying to evade, your standard phish detection and email security solutions. And the way they're doing this, of course, is they're just going around that. They're saying, well, let's just do smishing attacks, go through SMS. Let's do stuff where we try and send malicious links through, something like LinkedIn or some other social media avenue. Or let's provide documents that look clean, completely clean, but have some kind of malicious link inside the document. So trying to do different things within that capability to avoid what I mentioned before, those layers of email security we have in place to detect that kind of thing. The other interesting thing they're doing is trying to avoid web categorization. So obviously with the web gateway or proxy solution, you have categorization engines that try and block malicious content. So what attackers are doing now is there's a couple different avenues here. One is that they will look for sites that can be compromised. And again, back to that Log4j I mentioned before, most organizations, vast majority have fixed a lot of the Log4j issues. But there's this really long tail of Log4j vulnerable websites and other systems out there in the world that can be exploited by attackers. And so what they're doing is they're looking for that Log4j or anything else that comes out in the future. They're looking for exploitable websites to then drop their content into, because then they know, hey, this site maybe has been categorized as maybe a clean site. If I put my malware in there, I can easily get past into that categorization. The other thing they'll do is they'll actually load and create their own websites that are, maybe they look like a news site or they look like a sports site, and they'll actually sit on that site for months. They'll sit on it and basically with the end goal of hopefully having it categorized as one of those clean, quote unquote, clean sites. And then of course, what they can do is once they have been categorized as clean, they can flip a switch, drop some malware on there. And of course, anybody who goes to that site could be a victim for them as well. They're also using stuff like CAPTCHAs, right? They put CAPTCHAs on these sites to make them look more secure in nature. If for the average user, if they see a CAPTCHA, they're like, oh, that's a fine site. I can go ahead and click on that and go download any content. And they're sort of using that against the user themselves to avoid some of the protection layers we have. And then finally, some of the ways they use exploit code to evade stuff like HTTP inspection or visual detection capabilities. And so they're basically being able to do dynamic generation of JavaScript. And there's legitimate sites that do this, and the attackers have seen that as a legitimate thing. And so they're doing the same thing where they're basically using JavaScript that has been encrypted that has malware inside of it to evade those protection layers in the middle there. The other thing they're doing is with logo detection. One of the things that we see a lot of is the logo detection as being a big selling point to help block against, a site that looks like a PayPal or a site that looks like a, NBC or whatever it is, but they're using logo detection and logo generation capabilities to actually generate the logo inside of the browser rather than having that logo bypass through your visual detection engines. So they use some JavaScript and some nifty tools that actually go through there and reconstruct that logo in the browser after it's bypassed that layer in the middle. What I would say for a lot of these, all four of these, is we have some great blogs that our security researchers have done much deeper analysis on. So if you are sort of a security nerd and want to learn much more about how these things actually work in the wild, our blogs are a great place to go and look into this and give actual examples of how the attackers went about doing these various forms of attack that are part of the highly evasive adaptive threat category. So what are we seeing as far as our in the real world? And these sort of rendered a little bit funny. They have a little bit of weird things here, but that's fine. So between July and December of last year, we saw a 224% increase of attacks using these tactics by attackers, right? So just in that small time frame of a few months, we saw a huge increase of attackers saying, hey, you know what? These tactics are able to bypass a lot of the security that's out there. We're going to start using them. We analyzed something like 500,000 malicious URLs over the last 6 months or so. And of those, 69% of them use these tactics I just mentioned. Every minute, a new site's getting created that's a phishing site. As we know, it's very easy to spin up a site. We can all do it. I can go spin up a site right now, right? And so attackers use that same ability to create phishing sites, and they're using it to do impersonation of brands. So they're doing the brand impersonation, but like I said, they're doing the logo. They're using tactics to avoid logo detection to render that in the page to drop malware. And then in that ability of the attacker to basically have a non-malicious looking site that then turns bad, we went back in time even further as we saw the attackers using this back into 2019. And we saw that 950%, there's a 950% increase in attackers doing this tactic. So essentially taking a clean site, had probably been categorized as a clean site, flipping a switch, making it malicious, and causing obviously quite a bit of problem. So with that, I'm gonna go ahead and pass back over to Ryan to actually show you how some of this stuff works in the real world and how some of our technology can help protect against that. So it's off to you, Ryan.
All right. So those out there are familiar with the MITRE ATT&CK framework. Just to put it in context, you can do a search for HTML smuggling, for instance, and it'll pop up with the type of technique it falls under. And then there's a whole write-up on that if you're interested in getting a little bit more information on it. It tells you like the how to mitigate and detect it, as well as who are the type of adversaries out there that are doing this. But what basically, to give you some context here on what I have up, so I have my Chrome browser up, which is my unisolated browser, which means it's just going straight out to the internet. And then I have my isolated browser for Firefox, which is routing all of my web traffic through to our isolation platform. And this is also relevant back to the MPA conversation, where because we control and look at the browser session, we're able to do these type of inspections. So to give you an example, we have just a demo site here. I'm on my Chrome browser, and think of this too as like if I'm just browsing the web, or I know Eric mentioned the Log4j type of vulnerability that was out there. Maybe someone hasn't updated. Maybe you have gray sites. Maybe you have stuff that is old people are browsing to. What's happened here is what the evasive threats that the users in your organization could be clicking on. This is just an example of how this works, right? So as a user, I click on a site that I think is probably legit. You probably notice that this file automatically downloaded unbeknown to me. So this made it through some of the protections that I have even at home, right? I'm here in my office and it made it through some of the protections that I have. But one of the things that you're going to notice, this might get into the geeky, the weeds here from a geek perspective. But what you'll notice, and from a blob, if I were to look at the code that was actually downloaded, right? So in this particular site, there was a script that ran, and in this script, there's a base64 code, and it's a bunch of code here, right? So as going through protections, you can see that this particular script, when I clicked on that link, it automatically ran a script. And in that script, it it told it to download this PDF file. This PDF file was bypassing any of the security controls that I have in place and maybe potentially that you have in place. But this base 64 code isn't able, it just looks benign code that maybe firewalls, your layer 3 devices, security devices, endpoint stuff may not be able to pick up, right? So from a highly invasive type of attack, they're coding these type of attacks in the HTML code on the site that they go to, because there's no way to offset the type of traffic that comes to my endpoint, right? If I had a proxy in place, or if I had other type of content controls in place, if they're not able to decode this base 64 code that's embedded in this demo site, it would actually download malicious payload. Now, if I were to go, I'm going to switch over gears here to my Firefox browser. You're gonna see a couple things that are a little different, right? So same site, same everything. I'm going to click on the same link, and what's going to happen is, because we control that browser session, it's going to do a couple things. It actually, the site, same thing, try to download it, but because we're able to remove the interaction from the user and that site and sit in the middle, this is going through our isolation platform, in that it is creating these disposable containers in the cloud, running the content in the cloud, the scripts, the ads, the cookies, the redirects, all that stuff that could potentially be downloaded to an endpoint. It automatically pulled it up. The file tried to download. We have a secure document viewer where none of the malicious stuff could potentially compromise an endpoint, right? So these highly invasive threats are able to bypass normal controls. Now I'm going to switch to another tab here, same type of an example. So we have this tool, and anyone on the call today will be able to access this tool. It's basically, you go to heatcheck.security and you register for an account, and you can see in your own environment if your security controls are able to withstand these type of attacks. We have 3 examples that are published on the site. Some of you may be familiar with these type of attacks. There's a bunch of articles out there written on it. You can peruse that on your time. But in this particular example, it's really easy to check your own environment. So if on my unisolated browser, I'm just going to focus on HTML smuggling, it gives you the type of attack that it is. It gives you the details, and you can even check to see if you are protected from this type of an attack. So on my unisolated browser, you saw here that it automatically just downloaded that file, meaning it did not protect me from this type of an attack. If I switch over to my Firefox, which is my isolated browser, to do the same exact thing, what will happen is, instead of it just downloading, right, I can check, and this is for you guys to create your own account. You can go and just say, hey, check now. And if you are able to download that document, then there's some controls in place that need to be enhanced, because this particular example would be bypassing any of your security controls that you have. In this example, right, it was just an ICAR file, just to show you how we're able to obfuscate the type of attack that malicious actors do, right? So I was able to download it, and the ICAR is just a file that is standard for testing your security controls. It's been around for a long time. There's applications that should be able to pick that up. But in this particular type of an attack, it bypassed any of the stuff that I had in place. But because we are isolating all that traffic, it still goes into an isolation chamber. So this was an invoice.zip. I can actually go in and look at this, try to open it up. It's still in isolation. We never get outside of isolation. And because that type of that malicious payload is doing content on inspection in the back end, we're able to block the type of download that could potentially cause harm. So, and this also applies, I do want to tie it back to MPA, because this also, if I were trying to upload a malicious file to an application. So if you look at some of the statistics, I think Microsoft published a statistic from last year. They said that 70% of attacks start with phishing, and those phishing lead to 85% of web attacks with stolen user credentials. So if 70% start with phishing, then 85% of that start with web app attacks. Those web app attacks, if they're published and open to the world, you open and expose yourself to a potential breach. And so by offsetting the type of attacks to basically these users are obfuscating their code, you're able to protect yourself, even if you did have somebody who had stolen credentials in your organization and they got access to it and they're trying to maybe upload a file to an application, or maybe they're trying to compromise a machine. Because we're able to control that type of user session in the cloud in our isolation core, we're able to protect organizations from all sorts of attacks, not just these highly evasive, but any type of attack. And this also, I will say one last thing and caveat that with this also applies to email as well. So if you have phishing links that come in through email, I just showed you from a user perspective that it was just like a web perusing the web. But this also applies to links that users click on in their email, right? So they click on the links, it made it past, your email security, it made it past the scrutiny of that content filtered through email. They click on the link, and then the user could become compromised. And so this isolation technology, not just from outside in, but inside out, being able to protect the users wherever they are, and how they're accessing and interacting with the web and email. So I'll just switch that back to Eric, but essentially I would recommend checking out heatcheck.security and just seeing from in your own organization if your protections are able to protect against this highly evasive threats that are out there.
Cool. Hey, thanks a lot, Ryan. That's great stuff. And I don't know, you have to correct me if I'm wrong. I think you might have to go through one of you folks. Do you guys have to walk them through the heat check still, or is it a self-register, self-managed thing at this point?
Yeah, they can self-register.
Okay.
The only thing that we do have what's called Heat Analyzer, which is the next step where we plug into a Splunk environment that can analyze logs and see if there's any type of activity from a Splunk perspective to correlate. But this is just you register yourself, you log in, and you do it on your own. Yeah.
Cool. Yeah, good stuff. Thanks for walking us through all that. So the idea there, folks, is that obviously these attackers are never stopping. Unfortunately, there's a lot of motivation, whether it's financial, whether it's geopolitical, whatever it is. There's always motivation for these folks to try and find ways around legacy security or security that we have in place. And so this is one of that new class of threats that's doing that. And so it's definitely worth your while to sort of dig into it a little more, see how much exposure you may or may not have. I want to end with this one last slide, though, today. Give you a couple of things to think about on your way out of our session. Come talk to us. I mean, we have obviously, as far as a customer base we are trusted by a huge amount of very large customers. One of the biggest is, of course, DISA, 3.5 million users is one of the biggest customers in the world, right? And so they're on our platform. So obviously it's a proof point around how our platform can scale to whatever needs you might have. And of course we have large banks, all that kind of stuff across the globe. So a lot of customers trust us to bring security to bear in their organizations. And so we'd hope that you would take a look as well. If you're moving to SASE, of course, that's a big transition. So our whole platform can help you get there. We just talked about basically MPA today. There's some isolation talk in there as well. But of course, we have a full platform. Like I said, we have Web Gateway, DLP, CASB. We've got the whole platform that can help you make that transition along with your SASE journey. And then, as mentioned already by Ryan, a couple of things I would love for you to check out on your own or with us as well. reach out to your Menlo rep to do these kind of things if you need more information. But the heatcheck.security, go there, register, see if your security protects you against these threats. Right? Maybe you're protected. Maybe hey, everything's all good. But if not, if you are able to go to the heat check and you download, and one of those files gets downloaded automatically to your endpoint, that might be a problem. So we can help you solve some of that. And then, as also mentioned by Ryan, is our new tool called Heat Analyzer. And this is a Splunk base. And so basically what it allows you to do is take your logs that you have in Splunk and then run them through some backend technology we have to see if there's been any heat attacks in your environment in the past, right? So it'll give you a sense of if you've been perhaps probed or compromised or whatever it was by threat actors using these types of attacks. I think, and as Ryan mentioned, that's something we probably have to have a little more hands-on from us to actually get implemented and running. But it is definitely something we'd like you to check out if you are so inclined and you have Splunk in the environment. With that, I think that's the last slide I have for the day. So I think we pass it back to Cody for some gift cards. Hopefully you've all stayed on for some gift cards.
Awesome. Well, thank you, Eric, and thank you, Ryan, for taking the time to join us and sharing this with us. I'd like to remind our audience that the session was recorded. So following this workshop, you'll receive an email with a link to access the recording on demand. You can also find it living on the DevOps website at devops.com/webinars, and be sure to look in the on-demand section. So we do have those 4 $25 Amazon gift cards to give away. Our first winner is Diego M. Our second winner is Gwen P. Our third winner is Lena H. And our fourth and final winner is Rodrigo B.
So no, there's no Eric S. Cody, what about Eric S?
Oh, sorry. That was the fifth gift card I'm giving away. Eric S. Congratulations. So congratulations. Keep an eye on your inbox to claim that gift card. If you don't receive an email, just check your spam folder. Again, Ryan and Eric, thank you so much. I'd like to thank Menlo Security for sponsoring today's webinar. And to our audience, thank you so much for joining us today. We hope to see you at an upcoming Techstrong Learning workshop or webinar. And otherwise, have a great rest of your day.